minimas of the sine function. Here I have the graph of the sine function if you've never seen it before. And this tutorial will focus on the algorithm that is used to find the minimas. So if this is my function f, then the first thing I would do to find the minima or the maxima or the extremas in general would be to take f prime of x. And then the second thing I would do is I would set f prime of x to be equal to 0. So here, if this is f, then we know that f prime of x is cosine. You can check this using the limit definition of the derivative. And if I set it to be equal to 0, then clearly I have something that looks like this. And as you might already guess, extremas are x points such that f prime of x is equal to 0. So that is why we take the derivative, we set it to 0. Okay, but then if this is cosine of x, then what is the set of roots of f prime, which is the cosine function? Well, first thing you need to do is you need to actually draw function. And from here we see, so this is not 3 pi, yeah, so from the graph tells us that we have pi over 2 and 3 pi over 2. Then is this it? Are we done? Yeah, I mean, if you take the function on this very specific interval, then yes. But if you're taking the sine function, which is defined globally, then this is not true. Because here's the thing. The sine function repeats itself infinitely many times. And we would like to find the minimas accordingly. We don't want to find the minimas just on an interval. The first thing I'll ask is, okay, these are the roots. Just believe me for now. These are the roots on the interval from 0 to 2 pi. This is the notation for restriction. So which ones are the minimas? Which ones are the minimas of f? And the minimas of f are the ones where you have a minimum, right? So clearly it is not... Oh, did I erase the other one? Oh no. I erased the sine function. Oh no. Yes, so here you see that this is the minima really. It's not any of the other ones, because the other one is a maxima. So it's 3 pi over 2. It's not pi over 2, because at pi over 2 you get a maximum for the sine function. So here we have the minimum. So the minimum is actually 3 pi over 2. But then here's the thing. If I repeat this graph once again, just like this, it just you know, yeah, this is a perfect drawing. And then what really happens here is that you have pi over 2, but you've added 2 pi to it, because you've displaced it by 2 pi. This is the distance from here to there, it's 2 pi. Then you have here, change it by 2 pi. Then 2 pi, and then 2 pi plus 2 pi, that's 4 pi. And so you have the same interval, but instead of going from 0 to 2 pi, like here, you go from 2 pi to 4 pi. Now, again, pi is equivalent to 180 degrees if you've never seen it before. But I think you see the concept now. If this is 2 pi and this is 2 pi, then this is also 2 pi. So if I want to find all the maximas or the minimas of f, I better add 2 pi. But then I can do this multiple times. It can be 2 pi, it could be 4 pi, it could be 6 pi, it could be minus 8 pi, it could be minus 15 pi. Okay, no, it actually cannot, because they are multiples of 2. So I write 2 times pi times n, where n is an integer. So any integer value you multiply by 2 pi and you add it to 3 pi over 2 should give you the answer. And that is simply true because we can repeat the function. It's periodic. The sine function is periodic. The cosine function is also periodic. And so from this periodicity, we get this nice result about the roots of the cosine function. And then we conclude that this point is the minima by visually looking at the graph. Or you could do this by looking at the behavior of the function before and after. So if the derivative is, for example, positive before 3 pi over 2, and then it becomes negative, then what you have here is a maximum, because you get the highest point and then you start decreasing, and vice versa. And you can do this by plugging in values, but that is not the focus of this tutorial.